We are recording. So how was this exam from last time? Could y'all handle it? Well, let's check it out. So a ball is thrown in the air. The height of the ball above the ground is represented by this function, h of t. So if you give me a time, this function will tell you the height. And the time has to be in seconds. And if you give me the time in seconds, then this function gives you the height in meters. It doesn't tell you anything about how far the ball's gone left or right or any direction other than up and down. So remember, this is a quadratic or a polynomial of second degree. Okay, we're using t instead of x here. Um, so yeah, you can plug in any number you want into this, but we are going to restrict our domain. Since this is applying to a real world problem, t is our input, h of t is the output. We are only concerned with positive values of time because this does not apply for negative time. So we're restricting t to be between 0 and something. I don't know when, because we also want to restrict our range because we don't want a negative height because this does not apply. So our h of t uh, has to be bigger than or equal to 0. So these are our restrictions. It's kind of obvious though, whenever I draw it, we're only working in quadrant 1. So, all right. So from what height is the ball thrown? So this thing says a ball's thrown in the air, and then the height is above the ground represented by this. So what is the height at time 0? Time 0 is the moment the ball is thrown. So um, we want to know the height at time 0. This is called an initial condition. So initial conditions are like when you start out. It's also called a boundary problem. So h of 0, if you replace t with 0, you can see really easily you get 2. And since h is in meters, it's 2 meters. So I'm going to put a 2 here. I'm going to put like a dot because that is our y-intercept as well. What is the maximum height of the ball? Well, this is a parabola. The A is negative, so that means it opens downwards. So this thing could look like this, or it could look like this. Like I don't know where the vertex is, but wherever the vertex is, that would be where the maximum height occurs. Does that make sense? So let's find out where the vertex is here. Now, the time at which it happens is given by the vertex formula. So that's negative b over 2a. Remember that guy? All right, so somewhere it could be over here or over here. We're going to find out. Negative b 2.45 over 2a. A is negative 4.9. Now, since this is a word problem, we have weirdo numbers, so we're definitely going to use a calculator. 2.45, 2.49, and let's go to Desmos because that's where it's easiest. I recommend never using a handheld calculator. So I forgot my numbers. 245 and 4.9. 2.45 divided by 4.9, and the minuses cancel. So 0.25. And so this is exactly 0.25, and the time is in seconds. And this is a positive number, so it's over here. So I'm just going to put it like here, 0.25. So that's the time at which our maximum height occurs. So our vertex is on here somewhere. This is our axis of symmetry. To figure out what the height is, plug the time into the height function. So the height at 0.25 is negative 4.9. See, I'm just replacing t there with 0.25. 0.25 squared plus 2.45 times 0.25 plus 2. And now let's see if we can remember that. 4.9245. 4.9245. 4.9245. 4.9245. 2.45 plus 2. There we go. Now it might be easier to see if we used parentheses, you know. Now I'm going to show you a trick though. So check all this out. All right. That's our function. I replaced t with 0.25 and we're getting all this. Let's oops. I should have just typed it in. Why bother writing it down just to do this again, right? So does that look right? 0.9. Yeah. And theirs is so much prettier. Let's just use theirs, huh? Well, let's try this. Well, thanks for pasting it all huge. That's awesome. Equals. And this guy. Equals. There. And that shouldn't be there. Oops. Way prettier, huh? Let's get rid of this. So, okay, that's great. There's our height at that time, and h is in meters. So here's 2. So we need to go up there, right? And I'm imagining this might be rounded off. I don't know. No, it should be actually exact. Okay, so higher than 2, doesn't matter where, we'll put it right here. Let's put that in black. 2.30625. That's the height where the vertex is, right? So this guy looks something like that. We're not going to draw this part because it doesn't apply over there. Are y'all cool with that? Any questions so far? Okay. So we can answer this though. The height is between 0 and 2 point, whatever that is. 2.30625. So that's what we're restricting our range. Normally we would say it goes down forever, but it does not. Okay. Now, what's the next one? Stop me if you have questions, so I'm not just talking into the wind. How long is the ball at or above 3 meters? This is a good question here. So they're giving us a height, right? And then they want a time. Well, there's only 2 things here, time and height, right? Time is input, height is output. So what we're doing here is I'm giving you the output of 3 and you have to find the input, right? So here is our height. Okay. This is our height function at any time. And we want to know when the height is above 3 meters. So we're going to do above 3. So what we have is this inequality. So what we're going to do is solve this, but we're going to pretend it's equals first to solve that. Now, how do we do that? Well, um, this is a quadratic. Remember, if we have something like, here, we'll put our quadratic formula in here. Remember, if you have a quadratic, oops, bx plus, I got to get used to this new pen nib. If we have a quadratic that looks like this is general form, you can always rewrite it like this. Negative b plus or minus the square root b squared minus 4ac all over 2a. Right? Remember that, the quadratic formula? This is always the answers to that. So we need to put our dude into that form. Ours is not 0. But if we subtract 3 from both sides, negative 4.9 t squared plus 2.45 t, subtracting 3 from both sides, we get that. Oh boy, this pen is weird. I don't know about these new nibs. They're titanium, so they don't feel right. Okay, so for this, what we'll do is we can figure out where this equals 0, right? Where it equals 0. And then we will be able to figure out on which side of that value. So basically, there's t values, okay? There's going to be two t values. Like if this was equal to 0, there would be two answers, right? I'll call them t1 and t2. Okay, so where this is equal to 0, there's going to be two values where the height is 0. So that means everywhere else, it's either positive or negative. So once we figure out where it's 0, then we just can grab a test point and plug it into the height function to see if it's positive or negative. That's how we approach problems like this. So to figure out where this is positive, let's figure out where it's 0. We're going to need more paper here. So I'm going to take this guy, boom, move it down here. So let's move this guy too. To figure out where it's positive, let's find out where it's 0. Okay. And the quadratic formula will tell us, right? So I guess since we're calling it t here instead of x, what it should look like. There for us, since we call it t now. Okay, so where this is 0 is going to be at negative b plus or minus the square root b squared minus 4ac everything divided by 2a. Okay. Now, remember though, we are only concerned with positive t values. And there's two things going on here. So check this out. We can fix this because we don't want both of them. One of these t values is negative. But we need to kind of rearrange it to figure it out here a little bit, just to see it a little more clearly. So if you have a positive times a negative, that would be a negative, and a negative times a negative would be a positive, right? So check this out. So positive times negative is negative, and then a negative times negative is positive. So basically, we could just get rid of that minus sign that was there, because all that minus sign did was flip the order, and the order doesn't matter. It's two different equations, one of them with the minus and the other one with the plus. We want the positive one. So if we have a negative number and then we add something to it, that's going to be the positive version. Because if you have a negative number and subtract, that's a negative. So we don't want that one. We want the one where we're adding stuff. That's going to be the t that's a positive number. So we need to just plug this into our calculator and see what we can get. Oops, wrong button. Um, maybe I can. Oh, here's the fun part, trying to type this in without messing it up. It's hard enough to do it by hand, So what do we have here? The whole thing is going to be divided by, I'm going to do a trick here. 1 over 2 times 4.9. So that'll deal with the stuff that's on the bottom of the fraction here. So we're going to just take that and multiply it by a whole fraction. So basically what I'm doing is we could just multiply like that to get the same effect. Does that make sense? Y'all cool with that? Instead of dividing by this, I'll just multiply by 1 over that. It'll just be easier to type. So I got a negative 2.45 plus the square root of 2.45 squared. Let's see. Minus times a minus times a minus is a minus. There we go. 4 times 4.9 times 1. That's it. Where's the square root ending? Okay, that's good. And then boom. Undefined. Uh-oh. What did I do wrong? Beast. Uh-oh. We're getting an imaginary number in here. 4 times 4.9. 3 minuses. Let's check our math. Did I do something wrong? Negative b plus or minus square root b squared minus 4ac. Okay. Hmm. Um, why is it undefined? Well, let's see. What is this equal to? Well, C, V. See, that's a negative number. We can't be taking the square root of a negative because that would be an imaginary number. All right, let's back up a little bit. We want our height to be over 3 meters. Here's our height. So if we subtract 3 from both sides, we get this. Yeah, 2 minus 3 is a negative 1. Okay. Now, if we figure out where it's equal to 0, then, okay, well, maybe it has to equal 0 at some point. So t is negative b plus or minus square root b squared minus 4ac. Well, now my brain hurts. How long is the ball above 3 meters? Well, oh, duh, I'm doing this the hardest way possible. Check this out. This guy inside the square root is called the discriminant. All right. For us, this value is negative. So we're taking the square root of a negative number, which is an imaginary number. Why is this happening? Duh. Just regular old non-math. You know you're doing math when you don't do math. All right. Because the maximum height is 2.3 meters. So it's never over 3 meters. That's why we're getting weirdo math here. All right. So silly teacher. How many of y'all knew that and didn't say nothing? Y'all can hear me, right? Are y'all paying attention? All right. Y'all are supposed to be checking for brain farts, right? We just looked at it and said, well, the maximum height of the ball is this many meters. And then the very next question, how long is it above 3 meters? Well, if that's the maximum height, it's never. Y'all cool with that? So that one is way easier. I was like, why is this so hard? Any questions, y'all? Let's ask a better question. When does it hit the ground? A, B. So there's what is it? Part D. When does the ball hit the ground? Well, that's when the height is 0. And where's our height function? Here's our height. It's when our height is equal to 0. And when is our height equal to 0? Well, we could use the quadratic formula. Exactly when t is negative b plus or minus the square root b squared minus 4ac, everything divided by 2a. And again, we want the positive one here. So the positive times a negative is a negative. So we want the negative times the negative. Negative times the negative will leave us with a positive. That's what we want. So let's plug that into Desmos. What is this? 2.45, 4.9. Okay. 2.45. What is this? Negative b over 2a. No, hold on. A negative times a negative is a positive. So that guy. There. Approximately that many seconds. 2.267. So 0.267 approximately. So that's, but the way we should have done this right off the bat is plug this into Desmos. And this is cool. Watch this. 4.9, 2.45. So, and go ahead and here they want you to call it X. So we're going to call it X. Negative 4.9 times X squared plus 2.45 plus 2. Is that right? You don't remember now. Wait. Negative 4.9, 2.4. Oh, I forgot my X. There we go. Times X. We don't really need that times in there. That's silly. Oops. There. So the first thing you really want to do when, hold on, zoom kind of, I, where'd it go? There it is. There. So lots of bells and whistles with zoom getting in the way. So first thing you really want to do is just graph this thing, right? And then use their picture. Because theirs is way prettier than ours, right? So if I was doing this problem as homework, first thing I do is use Desmos to graph it. And then I know, oh, here's the vertex, right? So it's going to land sometime before 1 second and all that. But also, when you do your calculations, check this out. We don't need all this stuff anymore at all. There's the height function. And you don't have to put this h of x equals, but it's useful if you do because I can be like, okay, what is h of 1? What's the height at 1 second? It'll just tell you, right? Um, what's the height at, what is it? Negative b over 2a, negative b over 2a. Check that out. I don't even have to like type it in to the expression, right? I could just be like, I know h of negative b over 2a is that. See that? And then I just put my b and my a where they go. You could even be more awesome. Check this out. Oh, got a chat here. The mic isn't working. Okay. Uh, it's hard for me to see the chats. Do like emojis or something, maybe. Since we're going to be doing a lot of quadratics, here's another approach. Uh, so we are already done with that one. How about we do this? All quadratics look like this, right? This is what they all look like. Yeah. Now I could just tell it what A, B, and C are. A equals, what was it? A negative 4.9. And then B is 2.45. And then C was 2. Boom. So now on the next problem, I don't have to type all this stuff up here in again. I just tell it what my A, B, and C are, and it knows what the function is. Yeah. So we're going to do that. Now, uh, so using our tools, here's your quiz for today. Take a few minutes. And again, remind me at 4:14, I have to take a 5-minute break to go see my daughter get off the bus. Right? And I'm going to pause the recording and remind me to start recording again when we start back up. So take a few minutes to work this guy. Well, let's read it real quick. A half pipe ramp at a skate park is approximately in the shape of a parabola. If x stands for the horizontal distance in feet, something like that, from where a skateboarder starts a ride of the half pipe, and y stands for the height in feet, so y is the height at a given x, then the position of a skateboarder on the ramp is given by. So the height is given by the horizontal here. Find and interpret the vertex. Okay. So let's graph this. What are our A, B, and C? 4.42, 5.67, and 20. 0.42. So 0.42, negative 5.67, and 20. Is that right? I think so. So I don't think their half pipe goes off to infinity. All right. But think about this picture. Oops. One. There. And let's make it look more real here. Yeah, that's a little better, right? Okay. So let's label everything. Here is Y, which is the height after you take into account the horizontal. So this is the horizontal. And this over here does not apply. And I would assume that that doesn't apply either. Right? There's probably some like thing going on like that. Right? So this between here and here is where our function applies. Okay, that would be our restricted domain. Okay, and you could tell the A is positive, so it opens upwards. See that? And when the at x equals 0, you start off at 20. So that's why that's 20 right there. Oh, 20. Okay. Those are the things I'm just pointing out, right? So they want you to find and interpret the vertex. Okay. So y'all can do the math, but I can tell you what you're supposed to get right now. H of negative b over 2a. I don't even have to type them in because it already knows a, b, and c separately. You see that? See, that's the way you want to use a calculator. If you're going to use a calculator, use a calculator. You know what I mean? A computer, not no stupid little thingy. So let's move that. So whatever the x value is, that's it. And then if you want to figure out the y value, well, wait, no, wait a minute. I did it wrong. This is the y value. I'm so sorry, y'all. See it, we're plugging in a number and then the height, this is the height. So do 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 do. This is the 0.86, whatever, approximately, right? Okay. And then this is just the negative b over 2a, right? Don't plug it in first. So let's move this down. I can't do that. Negative b over 2a. There, 6.75. Oh no. Okay. But y'all know that. So y'all see if you can open up Desmos. Remember, just go to desmos.com, do the calculator, and I want y'all to set it up the way I did and uh, get the same answers, okay? So that y'all can start using this as much as possible so you don't have to do arithmetic anymore because that's no fun, okay? Nobody does arithmetic. All right, I'll give you all like 5 minutes to do get your Desmos setup, and then we're going to use it throughout the rest of the lecture here. Okay, class. How'd it go? Let's see. Oh, I never paused recording. Oh well. Y'all can still see the screen, right? Y'all get it all set up? So let's just do a whole snapshot of this. So you have it for later. Put it in the notes. So we know the vertex is always at negative b over 2a. And then when you want the height, it's always plug that in to the function. Right? That's it. See, it's way easier. Oh, we have to interpret it. Well, obviously, it is the bottom of the half pipe, right? Bottom. That's what it is. Easy peasy, right? So parabolas, nothing to them. All right, so we got 20 minutes before my daughter gets off the bus. Let's do some more here. Oh, I was going to paste this thing. That's right. So for future reference, use Desmos. All right. Go to desmos.com and then click calculator. And since we're going to be doing nothing but parabolas, I just put a generic parabola in there because they all look like that. And then all I have to do is tell it what my A, B, and C are. And now it knows my specific h of x. Okay. If I want negative b over 2a, I don't even have to like type these numbers ever again. Right? I just say that and it tells me what it is. And I want the height at that value. I don't have to type this in. Boom. That's it. Nice, right? And here's our, oh, I wonder, what's this? You also have the privilege of, check that out. Um, you can touch it. Let's see. I'm going to do that now. Yeah, I'm going to replace our little picture with a better one. Yeah. Let's learn how to use our tools here. So yeah, you can even make it labeled a point for you. Vertex. Yay. It does all kinds of crazy stuff. So we're going to use it a lot. All right, let's look at some more problems. Where's our book? Let's look at number 6 here. Boop. And you like that? Thought you might like that. All right. Science class. We're creating a container to hold an egg. Oh, the egg contest. You drop it from a window, and this height function tells you the height after t seconds. Okay. And we got questions. Okay. Height at a given time. Now, notice the height here is in feet. Time is still in seconds. And notice our A is negative 16, right? So this means A is negative 16, okay? Because H is in feet. Now up here, not that one, anything under gravity, something falling, the ball, okay? Here H is in meters, and our A, therefore, our A is negative 4.9. This has to do with the fact that gravity, all right, is pulling you down, but what's really happening is we are accelerating upwards. That's why it feels like if you accelerate in your car, it pushes you back in the seat. we're being pushed down on the ground because we're accelerating upwards at a rate of 9.8 meters per second. Okay. And meters, 9.8. Notice this is half of that. All right. But if you switch to feet, you have to change your A value. So this, if you're doing feet, that's going to be 16. If you're doing meters, it's 4.9. All right. And it's negative because it's pushing you down. Okay. The B's and the C's have to do with the rest of the stuff, but this is the acceleration. This is the actual gravity right here that's being applied. Okay. So it's always either going to be the negative 4.9 or negative 16 if it's in feet or meters. Just wanted to tell you that. Before we do anything, I'm going to use the software. Yeah, I want y'all to be able to look at these things and quickly glean stuff. We only care about positive time, positive height. And when height is 0, we're at 25. So I want y'all to be able to look at these and quickly see these things, right? Height is 0. So we start off at 25. Now, this is a positive number. Anything squared is positive, but there's a minus in front. So we're starting off at 25, and then as t increases, this is a negative number. So we have 25, and then we're subtracting from that. And then we subtract more and more as time gets big. So I could tell you right now, this thing doesn't ever go up. It's just down. Because again, 25, and then we're subtracting. There's nothing else to like add to the 25. Because the question I always have is, okay, it's a parabola, but where's the vertex? Does it go up here or is it over here? You see what I mean? So for this one, I know it goes down, but where's the vertex? Notice here that there is no just a t. Notice that our b value is 0 here, okay? And when your b is 0, remember, negative b over 2a. Well, if b is 0, okay, then that means your vertex is right here on the intercept. So these are things you can just see without doing much math. It's like, yeah, if I have a positive number and I subtract, then it's going to just get less and less. So those are the concepts I want y'all to pick up on more so than all the boring arithmetic stuff. The calculator is going to do that from now on, okay? So it's going to look something like that when we throw it into Desmos. So negative 16t squared plus 25. So A is negative 16. Our B is 0. And then C was what? 25. Boom. Now, like I said, now you might not like this picture. See how it's all just real skinny? And unfortunately, I can't pinch and just make it wider without making it taller. It really wants 5 clicks upwards to be the same length as 5 clicks sideways, but it doesn't have to do that. Here's how you fix that to get a better view. Go to settings. See, if it was a Mac, I could just pinch and zoom and it would do it, but Apple people didn't make this. You have x-axis, y-axis. So I only care about the x-axis between 0 and whatever value that is. So I'm going to do like 0 to 3 on my x-axis. I don't need negative numbers. I'm going to do 0 to 3. See how it changed? So now 1 tick mark to the right is not the same as 1 tick mark upwards. It just changed the scale. And I like that better now because I can see it better, you see? And you can also tell that the vertex is right there. All right, when we plug in 0, all right, we can do that. Oh, you can see it right here, a vertex. Negative b over 2a is 0 because b is 0. So h of that is just h of 0, and we don't need all these calculators to do this stuff, right? You can look at it and be like, well, right here, negative b over 2a is 0 because b is 0, right? And then the height at time 0, right? Plug this in, dude, right? Is 25. What is it? Meters, feet. Okay. And they always want you to say feet. Got to put the feet. That's how high the window is. We didn't need Desmos or anything other than understanding, but we had to know about that, the vertex formula, I guess. Um, but not really. You don't didn't need to know that if you know that if you have a positive number and you subtract from it, that it's just going to be less and less and less than 25. So the goal is to take the math out of it to where it becomes common sense. All right, find the maximum height of the container. Well, duh, 25 feet, right? Because what did we just say? It starts off at 25, and then as time passes, you're subtracting from that. So that's the max height. Oh, how long does it take to reach its maximum height? What? 0 seconds. It starts at its maximum height, right? That's the whole thing is you hold an egg in science class and you put it in a container and then the students get judged on whether the egg breaks or something. It's like a contest. You drop the egg at higher and higher and higher intervals until only one person's egg is not broke and they win. So never done that, but that sounds like fun. I think I'll do that with my daughter. Yeah, egg challenge. Y'all got any questions? Here, we'll take our picture of this thing here. Boop. Put it in our little notes here. So we learned something about Desmos, though, how to change the axis, though. Oh, let's see. There, right there. Max height. Yay. Okay. H of 0 is 25 feet. Yay. And we also learned from this example that's 16 when it's feet and 4.9 when it's meters because of gravity. Okay, let's do some more word problems. Where is our book? Eddie and the trampoline. So I didn't rent the bouncy castle because the trampoline I think is just going to be more fun anyways. And you got like 1,000 water balloons, the quick fill ones. Hopefully it keeps these kids busy. Okay, height, feet. Look at that, negative 16. T is in seconds. Yeah, this has to be seconds as well. Otherwise, that number will change. So, okay, Eddie's jumping. So before we do anything, quick, quick thing. We only care about positive time and positive height. At time 0, we're going to be at 6. So 6. And this is negative, so it opens downward. Now our vertex could be over here, or it could be over here. I don't know. Okay. But negative b over 2a, is this positive or negative? Well, it depends on a and b, right? If a is negative, oops, here, I'll use this. A is negative and b is positive, then minus signs cancel out, right? So this is a positive number. So that tells me that the vertex is over here in positive world land. And since it opens downward, it's something like that. Then all I need to do is find negative b over 2a and then plug that into the height to figure out what the actual height is at that time. and I know the vertex. But what's his question? Will he reach a height of 14 feet? Well, let's find the maximum height. All right, let's get a better picture first. Negative 16, 20, and 6. So negative 16, 20, and 6. There's a nice picture. So boom, we already see, here's our, let's take a picture of this guy. Well, actually, where's my vertex? Is this it? Usually it just kind of does it there. It knows you're aiming for the vertex. So there's our picture. Way better than my drawing, right? All right. So when you find your negative b over 2a, right? Plug that in, you get this guy, 0.625. And then you take that number and then you plug it into the height function right here. Plug it in there and there. And you put that in the calculator, pick, 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 pick. And then you see what comes out, right? You get this. So 12.25 is the maximum height, right? In feet. This is feet. In feet. Okay. So it never makes 14 feet. The highest is 12. No. Well, how tall is the trampoline? Well, it's probably the height he's at before he bounces, right? So what's the height at time 0? 6. And you can see that right here. Boop. 6. Oh, feet. We can't just say 6. That would be silly, right? All right. How tall is your brother? 40. 40 what? Oh, I got to get my daughter's measuring stick for her birthday to measure her height on. In case we move, I don't use the wall. I have a piece of siding thing. So I just bring that in. And okay, any questions about this one? That was easy, huh? Desmos is nice. I can't wait for Apple to release theirs on the iPad. Oh, where's my book? Book. Word pro. Oh, homework, page 131. So we want it to be red. Do your homework on page 131. Okay. Practice, and use the Desmos to do it fast. Right? So you can focus on the concepts and not arithmetic. Okay. Okay. What do we got? 131, 32, 33. Oh, look, see, I've already taught you all this stuff. Preparing to use the quadratic formula. They haven't even got to show you how to find the x-intercepts yet. But we've already learned all that. We'll stick it in the notes though, in case you forgot, right? Negative b plus or minus the square all over 2a. Okay. So yeah, grouping symbol. Well, when you use a real computer instead of that stupid calculator, it's easy to see what's actually happening. Okay. You don't ever use this symbol. That's not even on the keyboard, right? You don't use this, or yeah, you wouldn't do that. Don't do like 2 over 3. No, no, no. You can tell exactly what's being divided by what. So the way it's supposed to be. Now, we don't have to do all this. So all this is arithmetic. This is not algebra. Okay. And you know what? You don't have to be good at arithmetic to learn algebra when you have the computer do it. So there. Yeah, we could just, this guy, watch this. Fine. What is it? Square root of b squared minus 4a times c. You have to put a times c, otherwise it might think ac is its own variable, right? And we already have a, b, and c here, so it just tells you what the answer is. So for each one of these, instead of learning arithmetic, which I hope y'all can do this, okay? I hope y'all can do that. Practice it if you can't do this by hand, all right? But I mean, like the C here is 12. Here the B is positive, so you don't have to put parentheses. Okay? But the C is negative, so you do need to put parentheses so that you're multiplying. It would look weird to do a dot. Don't ever do that. That's ugly, right? Don't do that, right? If you have a positive times a negative, put them in parentheses, okay? If I if I just had this, if I just had that, I could use a dot. I don't like that because it looks like a decimal. Is this multiplying or is this a decimal? Right? So that's why I always do uh this pen nib. I always do it that way. And then also, since this guy's negative, you kind of have to have that in parentheses. Because if you just do this, you're subtracting. If you do that, you can do that, but it would look weird. See, like that looks weird because we're using two different notations for multiplication. I don't like that. I like to like pick one and use the appropriate one, you know what I mean? So that's no good either. Um, this guy is how I would write it. Then the rest is simply plugging it into your calculator correctly, right? All right. Remember, if your B is negative, because the B here is negative, you need to put the parentheses, all right, because it's getting squared, minus 4AC. And a lot of students, they won't write this because it's just one. I always put all the numbers there just because I like to be diligent and thorough, you know. But the important thing here is, right, B is negative, therefore use parentheses, okay? Because you're squaring the minus as well, okay? And yeah, B and C negative. Okay, all right, we learned that. And uh, these you need to be able to simplify without Desmos, okay? Um, all right, you do need to know how to do this because when you want your Desmos is good for rounding and all that like a calculator does. So word problems, use the calculator, but pure math things, don't use the calculator. Remember, square root. What you do is you look for a perfect square. 12 is 4 times 3, right? Okay. And the square root of a times b is the same as the square root of a times the square root of b. But remember, the square root of a plus b is definitely not the square root of a plus the square root of b, right? These are important to distinguish, okay? Because the square root is really an exponent, okay? That's what that really means. So This is square root of 4 times the square root of 3, and the square root of 4 is 2. So you would want to simplify this like that. If you can get anything out, do it. Now, you might not know if there's a perfect square in there. Do the prime decomposition if you don't know. 12 is 2 times 6. 6 is 2 times 3, right? This is 2 squared. So when you have a square root, it takes 2 copies to come out as a singleton. Okay. So I guess we could put it like this. This is the square root of 2 squared. There. All right, let's take a quick break, y'all. I got to be out there for my bus, for my kiddo. I'll be back in about 5 minutes, all right? Um, Go ahead and work the rest of these, all right? Computer here. Y'all can still hear me? Can y'all still see the screen? Is it working? Can you see me writing? Anybody? Can anybody say anything? Can you see me writing, y'all? I need input from y'all. Somebody.
Yeah, I can see you.
Yeah. All right. Cool. There we go. Okay. Cool. All right. So 72. If you don't know if there's a perfect square, we could think about it. That's our multiplication table. 70. Lily, shh, I'm teaching. All right. Let's see. I don't remember. I know it's 2 times 36, right? Yeah. Yeah. And the square root of 36 is 6. And then this poor little 2 here is left inside the square root. Okay. Now, so stop me if you have questions. Now, these, y'all are used to doing this, getting a common denominator and then putting them together. Okay. Y'all do that so much that you forget that you can go the other way. Okay. So this is 2 fractions. It's this guy and that guy. Okay. So we kind of have to go the other way with it. Okay. This is what I like to do anyways. So we have 10 over 4 plus or minus. The square root of 16 is 4. I guess we didn't have to separate them, but we could have just left it. I was expecting a different number. The square root of 16 is 4. So yeah, this is why I always separate it, because here I'm like, here I can just do 10 plus 4 and then 10 minus 4. See how it was just easier for me to separate the plus and minus. Then we can reduce. Divide the top and the bottom by 2. Divide the top and the bottom by 2. Y'all remember that stuff? 6 over 4. Remember all this? This is 3 over 2 and then 2 over 2. Since you're multiplying by the number 1. Okay. That's why students say you cancel them out, but canceling out is not an operation. Okay. But ignoring multiplying by 1 is totally fine. All right. Now, so those are your, oops. These are your 2 answers to this, because remember, this is 2 separate numbers. Okay. So sometimes students don't know when to go ahead and break it into 2 numbers or not. If you can easily separate it into 2 nice numbers, go ahead and separate them. Let's look at this one. -6 over -2. plus or minus. So we sub -2 on the bottom. What's the square root of 64? 8, right? Okay. Oh, oh man. Oh, that's too small. So what do I have here? Actually, the two minuses cancel. 6/2 is 3. Now the plus and minus, look, we have a positive times a negative and a negative times a negative. And then 8/2 is 4. So this is the time, right, we could just cancel those out. You could just throw this guy away. Why? Because all it did was flip this over. And this is the same thing as saying this, because the order doesn't matter. So keep that in mind. 3 minus 4 is -1, and 3 plus 4 is 7. So these are the two answers, regardless of the order, right? So if there's a minus down here, you can throw that guy away. Now, this guy, 2/2, plus or minus, there's our 2. The square root of 20. Well, 20 is a 4 times a 5, right? I did that because 4 is a perfect square. So 2/2 is 1. The square root of 4 is 2. And this 4, 5, he's left inside the square root. All right, so that guy came out. And we still got a 2 on the bottom. All right, this is why it's important to be able to simplify these, is because then you can simplify your fractions. So this is an example where I usually don't separate them. You can. Yes, we have this and we have this. I don't bother doing this. I would just leave it like that because this is the same thing as that. But these I do separate because you're getting two different numbers. You see that? But if I can write both numbers, I'm not getting anything extra out of turning this into these. So I would stop here. Okay. Now, again, you need to be able to do this arithmetic. You need to be able to do it so you get exact answers. Okay. When we're doing application word problems, use the calculator and you can round off wherever, however you want. Okay. When you're doing pure math, you got to do the arithmetic so you get exact answers. 15/6 plus or minus square root of 45. Well, if you think about it, that's 9 times 5, right? So the square root of 9 is going to be 3. That's why we did that. Now this guy, 15 is 3 times 5, and 6 is 3 times 2. The square root of 9 is 3, and then the 5 is stuck inside, and 6 is 3 times 2. So notice the order I wrote these things in so that you can just be like, those are both just the number 1. So we have 5 halves plus or minus the square root of 5/2. Now this does not simplify because 5 is prime. If I hadn't have known this, I could have done this instead. I know 45 is divisible by 5. It's 5 times 9, and 9 is 3 times 3. And then I could have looked and said, oh, there's 2 3s. So that's 3 squared. So they come out as a singleton, and then the 5 is left inside. You could do it that way mentally if you don't recognize this guy has a 9 in it, and 9 is a perfect square. Now this, when I have plus and minuses, I like to do it this way, separate the plus from the minus, but technically you could write it like this. You could write that, but because I don't like repeating myself, right? But more important for me is separating the stuff on either side of the plus and minus than avoiding rewriting the number two twice. So I like this better. They are equal, they're both fine. So because of this root symbol, it's good to be able to recognize your uh, powers. Two squared, two cubed, two to the fourth, uh, two to the fifth, two to the sixth, two to the seventh, two to the eighth, two to the ninth, two to the 10th. All right, help me out here. Three squared is nine. Nine times three is 27. I don't know what 27. I know this one's 81 because this is nine times nine, and that's three times three times three times three. I don't know what this was. This would be, uh, I don't know what goes here. I'd have to add, no, I have to multiply this by three. What is this? Anybody know? Six, eight. I guess this one does go here. Yeah, right. Yeah, I put it in the wrong spot. I don't know what goes over here though. Let's see. Do our little chart here. So this is the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th power. All right. So I need an A, right? A to the power. A. All right. And these are my A's. All right. So if y'all know more off the top of your head, let me know. So 4 squared is 16. 16 times 4 is 64. The way I do this is, check it out. 4 is 2 squared, isn't it? So if you know your powers of 2, you know the powers of 4. It's just going to be every other one of these, right? 64 times 4. 4 is 2 squared, right? So wherever this was, I'm just adding two more, right? So 256, and add two more. Ah, okay. And then we got what, 5? 5 squared is 25. 25 times 5, 125 times 5, right? Because I'm going to have 500 and then 5 of those. That's another 125. That's as far as I got off the top of my head. 6 squared, 36. I don't know what that times 6 is. Maybe I can remember it. I've never tried. 6 times 6 is 36. 18 plus 3 is 21. All right, y'all, here's the goal. If we ever have to deal with 6 cubed, we're all going to try to remember that it's 216. Try to add that to my repertoire. Okay. What about 7 here? 7 squared. Um, I don't know. What comes after that? I multiplied. Anybody remember 9 times 7? 9 times 5 is this, and then another two nines would be that, right? So 63. Well, how do we do this? I put the 6 up here. 28 and 6, 34. My brain is wearing out. 63. Thank you. Did I do this right? That times that is 3. Put the 6 there, multiply and add 6. 28. 6 to 30. Is that right? Is that how you do it? Well, I'm going to try to add some to my collection here. And then we're just going to go to 8 and 9 here. 8, 64. I don't know what the next one is. 64 times 8. This is 32. Oh, what is 8 times 6? 24 twice. 48 and 3. 51. Oh, I should have known that because this is 2 cubed, right? See, 64, 1, 2, 3. Yeah. And then 9. 9 times 9 is 81. 9 times 9 is 9. What is that, 72? Yeah, 729. That's new to me. All right, anyhow, and tens are great, but you should know your powers of two. You should know that, at least those. This is good to do because you can kind of do it in your head. At least know these, okay? All right, we're running out of time. So we need an exam. Daily exam, do. Daily exam, do. Daily exam. Okay, let's look in our book. Oh, imaginary numbers. I didn't get a chance to talk about them. Well, we got 2 minutes. Okay, check it out. I'll do two of these. So remember when you have, okay, the square root, what does that mean, square root? Well, if you have a square and the side is length x, then the area is x squared, right? Because you just take length times width. Okay, well, if I know the area and I want to know what the side is, it's called the square root of the area. So this is called the root, right? The square root. That's the length of the side. All right. So what would what would a negative area mean? Right? I know the square root of 4 is 2 because 2 squared is 4, but the square root of a negative would be like negative area and then trying to find the length of the side. So what we do is if there's a minus in there, you can always just do like that. This is 36 times a minus 1. So you can separate the minus. So yeah, square root of 36 is 6. And people got tired of writing this, so they use the letter I, okay, to denote the square root of the minus. So just call this I. Easy peasy. So this guy is just square root of 72, and then the minus on the inside, we just call it I. And then simplify that. So what is 72? 9 times 8? No, that's not right. 12 times 6, right? I think I screwed that up somewhere up here. This guy. Oh, we could do it that way, yeah. 72 is 36 times 2, isn't it? Yeah. Let's do that. That's better. 36 times 2. We still got our I. The square root of 36 is 6. The 2 is still left inside. And then we have the I to deal with the minus. Okay. So your job for your exam, now that you know everything there's to know about imaginary numbers, is to do these four. Okay. On page 134. And that's not enough. Um, where did it go? Oh, oh yeah. Yeah, and I want you to use your quadratic equation. All right. Let's grab a problem. Now, where's the quadratic formula? Throw it in there. Quadratic formula. There. Find the x-intercepts for this one. And 136. Okay. Find the x-intercepts. Okay. I'll call this number 17. And sure, you can see here, I'll give you the little graph, but don't just look at the graph, right? When I say find them, oh, come on. When I say find, I don't mean find, I mean solve for. Okay. And remember, your quadratic formula is this guy, ax squared plus bx plus c equals 0. This is important, is the same thing, that's ugly, as writing negative b plus or minus the square root of b squared minus 4ac, and everything's divided by 2a. Notice I didn't do this. Notice I didn't just do this, okay? Notice that this goes all the way to into that, and I do a little dip so we know where it ends. All right, notice the b is squared. Notice there's a minus here. Don't forget the plus and the minus. And honestly, I kind of like the equals to be in a line with the middle. So, this is equal to this whole thing. And there are two different equations because there's two answers, right? The y value for each of these points is 0 because we are on the x-axis. Okay, there's your test. Yeah. And all right, good luck, everybody. I will see y'all Thursday.